Quantitative research, variables, relationship between variables, null hypothesis. Should we reject or accept the null hypothesis? Is it a t-test or z-test, one-tailed or two-tailed, numerical or categorical variables? Are we going to use chi-square test? These complex concepts of statistics and research can sometimes be confusing. Different research topics, different variables, therefore different statistical treatments. But there are many statistical treatments that we can count. And the question is, what statistical treatments should we use? Hi, good day. I am your Sir Carlo, and this time we will be discussing another pivotal and vital statistical treatments that you can use in your quantitative research, which is the Pearson-R correlation. With the question, what statistical treatments should we use? Then this could be the answer. Pearson-R correlation is just one of the several statistical treatments that you can use in inferential statistics. The question is, when can we use the Pearson-R correlation? Let us learn this discussion later on. Let us begin by somehow analyzing these research topics. I have here three. First, the correlation between social media likes and frequency of posting contents. Which do you think are the two variables? Social media likes and frequency of posting contents. Let us identify the type of variable. Social media likes. Numerical or categorical? That is numerical. Frequency of posting contents. That is numerical. As you can see, as social media likes increases, as well, the frequency of posting contents also increases. Therefore, they have a positive correlation to each other. The second example, examining the relationship between hours of sleep and performance in video games. In this example, the lesser the hours of sleep, then the performance in video games increases. They are opposite. Therefore, they are negative correlation. And the last research title, for example, investigating the correlation between time spent on TikTok and procrastination level. Time spent on TikTok, numerical. Procrastination level, still numerical. And they both increase. Time spent on TikTok increases, while the procrastination level also increases. They are in a positive correlation. They both increase. With that, we can say that Pearson-R correlation can be used in both numerical variables. If you have two numerical variables, the variable 1 and variable 2, and you want to find the relationship between the two, then you can use the Pearson-R correlation. And there are two types of correlation, the negative and the positive. Let us learn about all these concepts later on. These are the learning competencies that we will be learning in this video discussion. Calculate the Pearson sample correlation coefficient. Later on, we'll solve some problems involving correlation analysis for you to have an idea of when are you going to use this in your research. And let us appreciate the purpose of this method. This is very useful in your research. Okay? So, why is it called Pearson-R, not the Pearson-R? Pearson, it is the surname of Sir Carl Pearson, who invented or who discovered this statistical treatment. Okay? How did he discover this concept? He discovered this concept by just a mere observation that most of the sons have the same height with his father. If his father is tall, therefore, genetically, his son should be tall. But that is not true to all cases. But most of the time, if you can observe in so many people, if you would agree. Okay. So again, if the father's height is high, let's say tall, then the son's height is also tall. if the father is short, then the same also with the son. Okay, that is how he discovered, and he also used so many variables, and he can say that most of the variables follow the same direction. Both increases, and sometimes they are contradicting to each other, and they allow us to pretty accurately predict one variable based on the value of another. You can make predictions. Therefore, Pearson R correlation measures the way two variables, which are both numerical, move together. How they move, increasing or decreasing, both the direction and closeness of their movement. So, for example, positive correlation. As the number of minutes of exercise daily increases, the more you exercise, therefore, the more healthy your heart is. Positive correlation. The same with the topics in the algebra. Look at the scatter plot. This is called the scatter plot. No. Look at the points. They follow a path. The path is going to the right, upper right. That is a positive correlation. But a negative correlation is opposite. It goes upward to the left. Okay? Let us learn some examples of positive correlation. Exercise and healthy eating has a strong association with excellent overall life longevity. Another example, the more educated you are, the more income that you will gain later in life. But again, that is not true to all, but most of the time we can observe that those who graduated with a degree can have much better income than others. But again, not true to all. Descartes sometimes works. Okay? Climate change and droughts. The higher the temperature, the higher also the frequency of having droughts. Gas prices. As gas prices increase, drivers tend to reduce the number of miles that they will drive. These are positive correlation. Again, both variables increases. How about the negative correlation? Number of cigarettes smoked versus the lung health. So, as the number of cigarettes smoked increases, then your lung health also decreases. They are opposite. The number of cigarettes smoked increases and your lung health deteriorates. Okay? Some other examples of negative correlations are the higher the sugar intake, then the lesser the oral hygiene. The more boozy that you get when you are drunk, then the lesser the coordination or malipong na ka, no? Then the interest rates and the house prices. As interest rates go up, house prices go down. Winter and ice cream. As the temperature increases, the more cold it gets. The more colder it gets, then the sales of ice cream decreases. They are opposite. Again, positive correlation and negative correlation. In the positive correlation, you can see they are grouped into two clusters. Okay? Upper cluster and the lower cluster. Upper right and lower left. And they follow a straight line or a linear graph, right? Positive line, positive linear graph. While the negative correlation is an opposite, it is a negative linear graph. It goes upward to the left. Okay? And again, they are grouped into two clusters, upper left and lower right. And the third type of correlation is weak or no correlation. They are really scattered to each other. They do not form a formation, a line. That's it. So to get around that, we use the standard deviations to scale our correlation so that it is always been -1 and 1. Therefore, our correlation coefficient, or we denote it as R, should be equal in between -1 and +1. So the values of person R should not exceed -1 and 1. Okay? Look at this. The +1 is a positive correlation. -1 is a negative correlation. Look at the graph. They are really following a straight line. Okay? But if you say -0.90, then there's a little bit a scatter plot, no? But they still can form one line. Look at this. Look at this graphics. You have -1. Okay. What have you observed? Okay. The more it approaches to 0, the more scattered it is. And the more it approaches to 1, +1, then the more positive it gets. And the same also with the negative, right? Can you observe? Okay. Still, we will be using the null hypothesis. Just like in the chi-square test, in the Pearson R test, always take note that the null hypothesis should be stated as there is no significant relationship. And the alternative hypothesis is the opposite. That is, there is significant relationship between the two. Okay, let us now go to the very important part, the most crucial part, the computation of the Pearson R. Well, I can assure you that this would be very easy, easier than the chi-square test, Pearson R, since they are both numerical variables. All we need to do is to use the formula, which is a little bit lengthy, but you can manage to do it. Just evaluate and substitute, then you can solve the Pearson R. Let us start with this example. Diba, we know that we use Pearson R if we have two numerical variables. So the two numerical variables that we have now are the scores of students in statistics and practical research. We hypothesize that if students are good in statistics, then they are also good in practical research. And the same goes with the -1. If they are not good in statistics, then they are not good as well in practical research. So different levels of skills of the students, different scores as well. But as you can see, look at the example here. 13 and 15, 9 and 10, 15 and 14, 4 and 6. What have you observed? They are a little bit closer to each other, right? If a student has a score of 23 very high, this student number 5, he or she also has a score which is high in research. Well, student number 9, very low score in statistics and also very low score in practical research. By this, we can hypothesize that statistics and practical research are really related to each other, because if students are good, then in both subjects, okay? But we need to prove it using the statistical treatment, which is the Pearson R. So we have now the step 1. Okay, let me check if it's recording. It's recording. We have the step 1. Okay, so in the step 1, it is blocked. Okay. Step 1, construct the table shown below. Complete the entries in each column. Get the sum of all entries below the columns. So let the statistics scores be X and the practical research scores be Y. Okay? X and Y, either of them, you can assign the two variables. Okay, you have it here. You just copy X for statistics, Y for practical research, 13, 15, 9, and 10, and so on. Then you add another column, the fourth column, X squared. Just squared the 13. 13 squared is 169. Y squared, which is 15 squared, is 225. And the last column is for x times y. 13 times 15, that is 195. After you compute each of the data or the value of each student, then sum it up. So you add 13 plus 9 plus 8 plus 17, then that is now the sum. Sorry, it is black, you cannot see it, but you can compute it manually, okay? I don't know why is it black, but I'll send the PowerPoint. Don't worry. Okay, so you have the Pearson R correlation coefficient formula. Look at the formula, it's very lengthy, but it is very easy to understand. Okay, so the formula is Pearson R correlation coefficient, or R, is equal to the number of respondents, or the sample size, in which in our case we have 10 respondents. 10 respondents times the sum of x, y. What is our x, y? X times y. This one here, this one. X, y, this one, okay? X, y. We cannot see it, but this one, you can see the arrow. Okay? Minus the sum of x. The sum of x is here, okay? If you add them all. Times the sum of y. So you multiply them first, and then you subtract them. All over the square root of the sample size again. Look at the bracket. Oh. They are both x in the first bracket. They are both y's in the second bracket. You multiply the values of x's and y's. Okay? So you look at this. Sample size times this, multiply the sum of x squared. So the sum of x squared here is 3,319 in this example. Minus the sum of x. Take note, these two are different. Look at this. You have x squared, which is this one, but the other one is the sum of x, which is this one, and you just enclose it with parentheses and then square them, and find for the difference and multiply the difference to the other bracket. The same goes also with the y's. No? The sample size times the sum of y squared minus the sum of y to the power of 2. This is the example. Now, let us evaluate this in the formula. You have it here now. Look at this. You have 10, the sample size, n, multiplied by the sum of x times y. That is 2,340, this one. Okay? Minus 138, which is the sum of, where's the arrow? Okay, which is the sum of x, sum of y, 146, all over the sample size again, which is n, times ex squared. The sum of ex squared is in here, this one. Okay, minus 138 squared, multiplied by this, and so on. And you use a calculator. Always take note of the PEMDAS so that you will not get wrong. And the answer is 0.96. That is positive. Okay? Positive correlation. And take note that the answer should not exceed -1 or +1. Okay? So you have this so-called strength indicator. Okay? The strength indicator. You have 0.80 to 1, that is a very strong positive correlation. So in this case, look at, you have 0.96. 0.96 is very strong positive correlation. Look at here. It belongs to this class interval, 0.80 to 1. Very strong positive correlation. Isn't it very easy? Again, let us recap the steps. First step, tally all the data, provide columns for x squared, y squared, x times y, then sum up everything. You have all the sums at the bottom rows. You have the step 2 is to use the formula, just substitute, and then operate on them and find the answer of R, then locate in which it belongs in the strength indicator, weak, as you can see, if it is negative, then negative correlation, positive, positive correlation. But they vary according to their scatter plot. Okay, that's it. And then you need to decide on whether to reject or accept the null hypothesis. Diba, we know that the null hypothesis all the time in Pearson R is there is no significant relationship between the statistics scores and practical research scores. There is no. Since it is a positive correlation, therefore there is a correlation. So we need to reject the null hypothesis because the null hypothesis is not true. Then we accept the alternative hypothesis. Okay? Gets? Again, if it is a positive correlation, positive 1, negative 0.9, negative 2, as long as it is a positive, then we reject the null hypothesis, which says there is no significant relationship. Therefore, there is significant relationship, the opposite of the null hypothesis. Okay? And otherwise, no? If it is negative correlation like negative 0.9, negative 1, negative 0.50, and so on, then we accept the null hypothesis. And that's it. Okay? In this case, we reject the null hypothesis. Very easy. Let us practice once more. We have here another problem. Okay? The number of absences and final grade. Look at this. We tried to compare if there is significant relationship. This student number 1 has 2 absences and his grade is 80. The number of absences of student number 2 is 0, therefore dako siya grado, no? High grade 92. The respondent number 3 has 3 absences and the score is 60. Yeah. So, do they follow the same direction? Let us see using the formula. So again, first step, do all the columns. You have x, y column, and then the x squared column. Hold on. Where's sample number 2? Ayan. Let me zoom. Can I zoom it in? Yeah. I can zoom it in. Okay. Later we'll zoom it in just to find the answer because it is blocked. So again, second step is to add all the columns for x squared, y squared, x times y. How to do it? Just multiply, 2 squared is 4, this one. Y squared is 80 times 80, 6,400. For x times y, 2 times 80 is 160. Okay, you do all these things in each respondent, and then you sum it up, you add them all. 2 plus 3 plus 1 plus 5, that is 11, and so on. You add them all, and you are ready to substitute the values in the formula. Okay, step 3 is to calculate the Pearson's sample correlation coefficient by substituting the values obtained from step 3 in the formula. Okay, so n, what's n again? The number of sample size or the number of respondents. We have 5 in this case, 5 students. X times y, the sum is here 675 here, minus the product of this, the sum of x and the sum of y. Where's the arrow? Okay, it's loading. Okay, so you have 11, which is the sum of x, and the sum of y is 370. Okay, all over the square root of n, again 5 times sum of ex squared, and so on. You can substitute them and use a calculator. You can do it manually again, and the answer is negative 0.21. This time it is a negative correlation. Therefore, where does 0.21 belong? Let us see. Oh my god. Let us see it in the, where is that? Okay, so negative 0.21 belongs to weak negative correlation. It's in here. Hold on. Okay. Weak negative correlation. That's it. And Should we have another example? Okay, another example. The number of hours in playing online games and the final grade. Okay, how can we, let's say, hypothesize? As the number of hours in playing online games increases, can we say that their final grade decreases? Decreases? Let's find out. Just look at the data. You can observe the same process. What's happening to this? Okay. So again, step 2, comply all the tables, sum all the tables. Step 3, you can just scan it here. The same process, substitute, and then you have the final answer, negative 0.08. That's negative correlation. Let us locate in the strength indicator that belongs to the very weak negative correlation. And how do we hypothesize? There is no significant relationship between the two variables. Therefore, we accept the null hypothesis. That's it, and this is your activity today. Kindly answer from 1, 2, and 3. Write it in a one whole sheet of paper. Kindly submit this before 5 p.m. Thank you so much. Should you have more questions, just don't hesitate to PM me. Okay, that's it for this lesson, and again, you may ask questions if you want. Just replay the video so that you can understand the very simple concept of Pearson R. Thank you so much, and goodbye. Have a great day.